Hello everyone, my name is Vinayak Mane. This project is a production grade retrieval augmented generation system built specifically for the academic paper from the arxiv. So it automatically ingested papers, process their PDF, build a hybrid search index, and answers research question using a local LLM. The entire system runs as a microservice stack with Airflow, OpenSearch, PostgreSQL, Redis, Olama, FastAPI, and Langfoods all orchestrated together through Docker. I'll walk you through how it works end to end and then show a live demo as well. So on the screen, this is my architecture diagram. I'll just give you a quick overview. The fast API serves as a backend API, which handles search, metadata access, and RAG queries. PostgreSQL stores structured information about each paper, such as ID, title, authors, category, and publication dates. Then the OpenSearch holds the chunk level index with both keyword BM25 fields and semantic embeddings, enabling hybrid search. Then the Airflow orchestrates the ingestion pipeline, like fetching new papers, parsing PDF, chunking, embedding, and indexing. Olama serves the language model locally for question answering. Redis provides low latency caching for repeated RAG queries. Then the Langfuse gives full tracing across embedding, search, prompt construction, and LM generation. So these components communicates cleanly and can scale independently. The system behaves like a small-scale production RAG service. Now, let's go into the ingestion pipeline with the Airflow. So this is my ingestion pipeline with the Airflow. I'm using the stack. And this is the graph of the DAG. As you can see, setup environment, fetch daily papers, index paper hybrid, generate daily report, and clean up template file. So every run perform a sequence of operations. So first one is fetch new papers from the arxiv. The pipeline queries arxiv API based on the configured categories like cs.ai or cs.lg. It handles rate limit as well and safety skips papers that have already been processed. Uh, then the peer download and pass, then it downloaded and passed the PDF. PDFs are extracted using a modern scientific document parser that preserves headings, sections, tables, and mathematical structure. This results in a clean structured text rather than messy raw PDF extraction. Then the intelligent chunking, the content is segmented using a section hour strategy. It tries to preserve natural academics section boundaries. Larger sections are split into 600 word chunking with a small overlap. Then it does the embedding. So each chunk is converted into a 1024 dimensional semantic vector using Gina AI's latest embedding model. Then it does indexing. The raw text and the embeddings are written to the OpenSearch hybrid index, while paper level metadata is stored in PostgreSQL. The pipeline is idempotent, which means fault tolerant, idempotent and fault tolerant, and provides clear logs and metrics after each run. I'll just quickly show you one of the logs of my one task. So this does not run properly, I guess. Let's go into this one. Yeah. Okay. So yeah, this ran properly here. Yeah. So it fetches the daily paper, then it indexes into that. So it says that the total paper processed are 15 and total chunks created are 211. Then the total chunks index are 211 as well. Right. So it's working perfectly. And I can also trigger from here using this one. Currently scheduled at 6 a.m. UTC. Now let's go into the dev tool of the OpenSearch. So so here I'm currently I'm retrieving a few chunks document to show that the ingestion pipeline successfully populated the ingestion. Each entry corresponds to a chunk of paper containing the arxiv ID, title, others, abstract categories, publication dates, and chunk text. If I run this, it will show me these details over here. Then I'll run a more meaningful search. This query uses the BM25 keyword engine and applies field boosting, which prioritizes matches in the title, then abstract, and then others, and so on. So this is the deterministic side of a hybrid search, perfect for exact terminology. Let's run this one. Right. So it's giving me a few chunks over here. Now let me show you my Gradio application. So if I ask this question, what are transforming machine learning, I'm using the 3 chunks over here. So it will probably give me answer quickly because it's using the cache. And like I already asked this question, so it's giving me quickly here. If I ask the question again, it will give me immediately. It's also showing me which mode we use for free answering, which we use the hybrid mode for searching in open search, and chunks use are 3, and the sources are this. So these are the papers we have used for answering this question, and it answers correctly. Right. Right. Now let's go into the observability layer with the lang views. So that's my tracing here in the lang views. This is my dashboard, which showing everything. Currently, the model is free, so it does not showing the model usage. We are using the running the Olama on the local server. Showing the traces over here. Let's go into the first trace, and yeah, that's my showing my answer over here, and the total duration seconds are only 0.014. But previously I ran this, and it took around 3 minutes to answer the question. But now, as we can see here, it only took 0.014. So that's really, really fast using the caching. In practice, this reduces latency from several seconds to under milliseconds, and can eliminate more than half of our repeated LLM calls. Right. Now let's see the design architecture. Right. So all my code is organized. Main code is organized under the SRC folder. The backend follows a clean architecture approach. The first one is router, which exposes the minimal HTTP endpoints. Then the service, which hold all business logic like search, embedding, RAG, orchestration, caching. Then repository abstract the database and open search interactions. The schema enforce strong validation and type safety. Configuration is centralized and environment driven. Dependency injection makes everything testable and swappable. So this structure ensures maintainability, easier debugging, clean separation of concerns, and the flexibility to replace my component, for example, switching LLMs, changing embedding models, or adding new retrieval strategies without rewriting the whole system. So to summarize the stack, fast API for async APIs, PostgreSQL for relational metadata, OpenSearch for hybrid retrieval, Airflow for workflow orchestration, Redis for caching, Olama for local LLM inference, Gina embedding for retrieval optimization, Docklink for robust PDF parsing, then Langfuse for tracing and observability. So these are like some of the production level features, which are includes health checks, idempotent ingestion steps, graceful fallback modes, structured loggings, hybrid search with tunable ranking, automatic caching, and horizontal scaling at service level. So the system behaves like a real world RAG service engineered for reliability. So that's the complete workflow from automated ingestion, structured parsing, intelligent chunking, and hybrid search to real-time LLM backed answer with caching and full observability. The system is modular, extensible, and designed with production principle in mind. Thank you for watching this video.